So next we are coming to the topic Ohm's law. Okay, so here in this topic we are going to see, is there any relation between the potential difference across a circuit and the current passing through it? So for this, let's analyze three scenarios. In one circuit, I am connecting a bulb without giving any potential difference across it. In the next scenario, I am connecting a bulb to a 2-volt cell. In the third scenario, I am connecting a bulb across 2 cells of 2 volt each. Okay. Now, what happens in the first case? Whether the bulb will glow? No, the bulb will not glow. As you can see, there is no potential difference across it. There is no energy source to cause the electrons to flow. So, there is no current in it. But what happens in the second case? In the second case, the bulb glows because a current passes across the bulb as it is connected to a energy source. Now, what happens in the third case? Yes, here also the bulb will glow as the bulb is connected across a battery cell of 2 volt each. So, what is the total potential across it? It is 4 volt. Now, in both these cases, which bulb will glow more? Yes, the third scenario. The third scenario, the bulb will glow more. From this, what can you understand? Yes, as the potential across a circuit is more, the current is more. Okay, so in both these circuits, which circuit has more potential? This one, right? So the current in which circuit will be more? This one. Followed? Okay. So from this we can write the inference as voltage increases, current increases. Okay, given the resistance is constant in that circuit. Okay, so the Ohm's law states that as long as the circuit remains the same, the potential difference across a circuit is directly proportional to the current through the circuit. Okay, so what does Ohm's law states? As long as the circuit remains the same, the potential difference is directly proportional to the current passing through the circuit. Okay, followed. So we can represent this in the form of a formula. See, V is proportional to what? I. The potential difference, voltage is proportional to the current. To change this proportionality symbol, we will use a constant. That is, V is equal to R I. Okay, so see here, this constant, the proportionality constant used is R, which is known as the resistance. What? Resistance of the circuit. I will explain what is resistance. Okay, and I is what? Current. And what is V? Voltage. Okay, now tell me the units. What are the SI unit? Voltage. It is volt, represented by V. What is the SI unit of current? It is ampere, represented by A. What is the SI unit for resistance? It is ohms, represented by the symbol. What is it? Ohm, O-H-M. Followed. So, if I am quoting the voltage and current in a circuit in the form of a graph, see, I am quoting the voltage on the x-axis. Okay, I am quoting the current on the y-axis. What happens? See, let us give a numericals. Okay, when voltage increases, what happens to the current? The current will increase, right? So, what will be the shape of a VI graph? Okay, this is a straight line. Okay, so as voltage is increasing, the current is increasing. That is what this graph implies. See, as voltage increases, for this value of voltage, this is the value of current. Okay, for this value of voltage, this is the value of current. So you can see, as voltage is increasing, the current is increasing. And what does the slope of VI graph implies? What is the equation of voltage? V is equal to IR, where R is the resistance, I is the current, and V is the voltage. So the slope of the VI graph gives the resistance of the circuit. What? Resistance. Slope. Okay. Slope gives what? Resistance of the circuit. Followed. Okay. Okay. For you to remember this formula, see, let us construct a triangle. We can call this as the Veer Chakra. V-I-R. Now, you can memorize this triangle, right? Veer Chakra. V is equal to I into R. I is equal to V by R. R is equal to V by I. Okay, easy, right? So, what is the formula? V is equal to I into R. I is equal to V by R. R is equal to V by I. Followed? Okay. And the resistance for two metallic wire of same material at same temperature is same. So, you can write resistance as what? Resistance is a constant. It is constant for a given metallic wire at a what? At a given temperature. Okay, followed. Suppose I am telling I am having two copper wires of same length, same area, everything. Okay, and I am giving as the resistance of one of the wire is 10 ohms, and both the wires are at same temperature. So I am asking you, what will be the resistance of the other wire? See, both the wires are of same metal and the temperature is also the same. So automatically the resistance of this wire is also 10 ohms. Followed? Okay. So, let's solve a question. See, potential difference between the terminals of an electric heater is 75 volt. So, V is given as 75 volt. When it draws a current of 5 ampere from the source, so current I is equal to 5 ampere. what current will the heater draw if the potential difference is increased to 150 volt? So initially they are telling when the potential was 75, the current was 5 ampere. Now you have to find out if the potential is 150, then what will be the current? Okay, so what is our formula? V is equal to IR. Am I right? So to find I, what you want? V by R. Right? So this is the equation that you require here. So here you have V. Do you have R? No, R is not given. But you can find out R from here. From here, what is the equation for R? R is equal to, remember the Veer Chakra, V I R. What is R? R is equal to V by I. V by I, which is equal to 75 by 5, equal to how much? 15 ohms. Right? R is equal to 15 ohms. So substituting the value in this equation, I is equal to V by R. What is the V given? 150. What is the R obtained? 15. Why the R is same? See, it is the same circuit. We are not changing the circuit. So R is a constant here. Okay. So what we got? It's equal to 10 ampere. The current is what? 10 ampere. Followed. So next we are going to study about resistance and resistivity. What is resistance? What is resistance? It is the property of a conductor, or it is a property of a material to resist the flow of current through it. Okay. So what is resistance? It is the property of a conductor to resist the flow of charges through it. Followed. So now tell me, for a good conductor, will the resistance be on the higher side or the lower side? Okay, so what is the property? Resistance means it will resist, it will prevent the flow of charges. The current will be there in the circuit only if the charges flow properly. Okay. So in a good conductor, the current flow happens very efficiently. Means the current is conducted in a good manner. So the resistance is low for good conductors. Followed. And the resistance is very high for poor conductors. So what is second point? In good conductors, the resistance is low. Followed. What is the formula for resistance? R is equal to V by I. What is the SI unit? SI unit is ohm. Followed. Now, what is defined as 1 ohm? See, when the voltage in a circuit is 1 volt and the current in a circuit is 1 ampere, what we get? We get the resistance as 1 ohm, right? So how can you define this? If the potential difference across a circuit is 1 volt and the current passing through that circuit is 1 ampere, then the resistance across the circuit is said to be 1 ohm. Okay. If the potential difference across a circuit is 1 volt and the current through the circuit is 1 ampere, then the resistance of that circuit is said to be 1 ohm. Followed. This can come for your exam. They can ask you define 1 ohm. Okay, so you have to write this. Followed. You can copy the notes. So, we have learned about what is resistance. Now, let's come to the factors that affects the resistance. Okay, so there are 3 factors affecting the resistance. What is the first one? First one, length. The length of the material. Okay. The second one is the area of cross section of the material. Area. Okay. Third one is what? What is third one? Third one is what? Nature of the material of the conductor. Okay. Nature of the material. Okay. Now, let's see what happens with length variations. If the length of the conductor is increasing, what happens to the resistance? See, in the first case, the length is directly proportional to the resistance. When length increases, resistance increases. Followed. Okay, for you to understand, I will tell an example. If you are traveling on a road with a traffic jam, if the length of the road is more, you have to cross all those and go ahead. Means the resistance is more, the obstruction is more. Literally, resistance is what? It is the obstruction caused to the flow of charges, right? So, similar in the case of a traffic jam on a road. If the length of the road is more, means what? You have to travel, you have to pass all the obstructions, means the resistance is more. So, as the length increases, the obstruction increases. That means as the length increases, resistance increases. Followed. Now, same case. What happens when area of cross section of the material increases? Area of cross section, here length is directly proportional to R. Now coming to area. Area is inversely proportional. Followed. That means what? When area increases, resistance decreases and vice versa. When area decreases, resistance increase. When area increases, resistance decrease. It is the opposite. Same case, if in the traffic jam, if the width of the road is more, you are getting more space to travel, right? So the obstruction is becoming reduced. Followed. Same happens in the case of a conductor. Okay, when the area of cross section increases, resistance decrease and vice versa. And what is the third factor? It is the nature of the material. So the resistance is different for different materials. Okay, it is not same for all the materials. For one kind of metal, the resistance will be one value, and for other metal it will be different. So it also depends on the nature of the material. Followed.